Hello guys, welcome to Position Time Graph. This video is about connection of x to t. Okay? You remember previously I talked about the concept of position, displacement, distance, and time. Now we are connecting them in one dimension. Let's have a review over the one-dimensional motion. Motion in one dimension means that the object that moves is constrained to move along a straight line. Suppose that this man promised to move on horizontal axis. Let's say it's x-axis. He starts from x equals 0. The initial position goes for a few meters and stops. Destination is x equals 10. And the displacement of this man is going to be 10 meters. Till now, everything is okay, but I believe that every event in physics takes place in time. But time now is hidden, and I don't see any time. How to connect time to x is exactly the mystery of XT graph. So let's continue with time-lapse photography or periodic imaging. For this time-lapse imaging, I make the condition of delta t equals 1. Every 1 second, I will take a picture. Look at this car. It starts from here, goes to the right at constant speed. Constant speed is called uniform motion. In uniform motion, we expect equal delta x in equal delta t. So delta x1, delta x2, and delta x3 will have equal values as the delta t is the same for all, 1 second. In uniform motion, the speed keeps a constant value. The second car has a different behavior. At the beginning, it's very slow, and so it's getting faster and faster as the time goes on. So delta x1 is smaller than delta x2, and delta x2 is smaller than delta x3. This type of motion is called a speeding up motion. The last one has again a different behavior. At the beginning, it's very fast, and then it's getting slower, and finally it stops. So delta x1 is the largest, delta x2 is smaller, and delta x3 is the smallest. This type of motion is called a slowing down motion. You see, anyway, time is still hidden, but I think that we have already included the time. As we have a periodic imaging, I have more information about the motion. As you see, the first, the second, and the third car will have some different behaviors and different types of motion. So I can understand that if I include the time, I will have more information about the detail of motion. So I prefer to have another axis to combine with the x and make my xt graph. So let's continue with some numerical values. Again, let's consider motion, uniform motion, starting from x equals 2. And let's call x equals 2 as initial position. And let's have a stopwatch here to record the time. And in every 1 second, again, I will take a picture. Don't forget that this car also will have a uniform motion. So it will have equal delta x and equal delta t. So let's check it. Yeah. For t equals 1, the car displaced for 3 meters and then gets x equals 5 and then continues to 8 at t equals 2 and then t equals 3, x equals 11, and finally it will get the destination t equals 4. During 4 seconds, the object has displaced for 12 meters, as I see. Okay, then I try to make something like this, xt graph. In xt graph, I prefer to have a combination of both axes. What do I mean? Here I have xt graph, vertical axis is exactly the horizontal axis I have already introduced. I mean, the horizontal x is exactly the vertical x here. It's the same, but I have just rotated by 90 degrees. And then on horizontal axis, I put time. And let's take the unit of the time to be second. At the beginning, at t equals 0, you know that the object has been at x equals 2, so it is 2. And then for the next time, t equals 1, the car has been in x equals 5. So for t equals 1, x equals 5. Then we continue for t equals 2, in which I will find the car at x equals 8. And then I continue for t equals 3, in which the car will be at x equals 11. And finally, here I see it's at x equals 14 in t equals 4. So finally, I will have 1, 2, 3, 4, and 5 data points. Means that here each point will indicate a time, a moment, and a position. So I can put my pencil here and draw a graph. I connect these points and I see it's a line. So graph in uniform motion indicates a linear behavior. So mathematically, graph for this type of motion, the uniform motion, must be a line. If I take more and more exposures during the motion, I mean, why should I take delta t to be 1? It could be even 0.1 second. So every 1/10 of a second, I may take an exposure. So in this way, I will have more and more points in the way. So even if I do that, I will have some more data points. And if I connect all of them, I see again the same linear behavior. I mean, in uniform motion, it doesn't matter if you take just 1 or 2 or even 1,000 exposures. Generally, graph will be a line. What about in the case of, I mean, speeding up or slowing down motion? Do we have the same linear graph? Let's see. Suppose that the car is, again, in x equals 2, and it starts from here to go rightward, but with speeding up motion. So here in 4 seconds again, I have taken the pictures every 1 second, but the distance, you see the distance traveled in the first time interval is 0.3 meters. The second is larger, the third and the fourth are going to be larger and larger. Here the graph is going to be like this. At t equals 0, x is 2. T equals 1, x is 2.3. T equals 2, x equals 4. T equals 3, x is 9. And at t equals 4, x is 14. So I will have these data points. You see that I cannot connect these points with a line. And if I want to connect them by a smooth graph, normally this smooth graph could be a curve. If I take more and more exposures, I mean that I reduce the time interval to very small, very short time interval. So I may have 1,000 points. Normally, I will have some more and more data points. And if I put my pencil, hopefully for finding a smooth curve, I may have something like this. It is not a line. Anyway, it's not a line. So for speeding up or even the slowing down motion, as the speed is changing, I won't expect the same delta x in the same delta t in upcoming seconds. So I prefer to check the graph in a different way, not a linear one. I should have something like this, a curve. Okay, let's continue and let's check our understanding. Suppose that on horizontal axis, which is x here, I have some points taken as the position of an object moving to the right side. Let's say right side is forward or the positive direction of x, and the time interval is everything at 1, maybe 1 second, everything, but equal. In equal time intervals, the object has displaced for equal delta x. So I think the linear behavior is evident, so it's a uniform motion. The second case may indicate the speeding up. So you know that in this case, I will have an graph which is not linear. Maybe a curve like that. But what if the graph is given like this? It's just slowing down. You see in the second in the second delta x2, in the second delta x, and in the first delta x, I will have different values, but delta x2 is smaller than delta x1, and delta x3 even smaller than delta x2. So it's going to be smaller and smaller as I continue. Let me show you something. Suppose that this is the xt graph, okay? If I draw the xt graph like this, it is not normal for that because it's speeding up. What do I mean? Suppose that this is 1 second and then it is again another 1 second and again another 1 second. If I draw this like that, I expect larger delta x in the upcoming time intervals. You see, delta x1 is here, delta x2 is here, and delta x3 is here. So this type of motion is not accepted. I think for the slowing down motion, I expect something like this. Let's say this is the xt graph, and then I draw it like that. It is again not a linear graph, but as you see, if I take, for instance, delta t to be 1 second here, and again another delta t to be again 1 second as the time interval, here you see in the upcoming seconds, the object will displace less. I mean, delta x1 is larger than delta x2, and delta x2 even larger than delta x3. So it's going to be a slowing down motion, okay? So I think here you can persuade yourself that xt graph must be a nonlinear curve, but like this. Later in the coming videos, I will have a full discussion about the mathematics behind this xt graph, and so you will learn it more. But just please, for the time being, accept it that xt graph must be like that for slowing down motion. Non-linear anyway, but something like this. In mathematics, we say the slope of this motion, slope of this xt graph is going to be smaller. So the speed of this motion is smaller. The slope, later we will see that, the slope of xt graph is the velocity, and so the velocity is smaller. Here the velocity as the slope is going to be larger. And so it's exactly the mathematical difference between these two graphs. But later I will discuss why the slope is the velocity and what the velocity is, basically. Okay. Let's continue, but by some key expressions. Let's check our understanding. Suppose that the xt graph is given like this, okay, and the object starts from xi. Xi is initial position, okay. Finally, and also the time ti, initial time, initial moments. And finally, the object gets xf. Xf is going to be final position, and the time is tf, final moment or final time. From xi to xf, I can draw a vector. Okay, a vector starting from the initial position and ending at xf, the final position. It's going to be the displacement, and we had a complete discussion about the displacement in the previous video, so you know what the displacement is. Okay, look at this object. This object is at rest, means that this toy car will be here forever. In the coming seconds or moments, I will find the object exactly at this point. Also, if I draw the xt graph, it will be a horizontal line with no slope. What does it mean? It means that at t1, the object is here. At t2, again, the object is here, and blah, blah. So I won't have any change in position. On the other hand, if I have a uniform motion, let's say it's forward, and if the object starts from negative x, you see the initial position is negative. So it's also possible that the toy car starts from negative x. It will have a linear graph. You know why. So this xt graph is linear, starting from a negative, and then it will pass through the origin and then continues. What the origin means is exactly x equals 0. So at this point, when the xt graph is crossing the t-axis, we expect that the x to be 0. Means that the object is passing through the origin, but it has the same speed. You know that the speed here, it will be the same. because it's a uniform motion. So even when the object is crossing the t-axis from x equals 0, we expect the same speed. It won't stop, never. Okay, something may be interesting for you, that when I check the object at t equals 0 and I want to see the position, to find the position of the object, the location of the object, I can easily do something like that. At t equals 0, I will go to the graph and I find the object here. The graph can show me the location. Here at t equals t1, let's say it's t1, the object will be here. I come down, I get the graph, and then I go to the left. And so the object is here. We continue here. Oh yeah, it's interesting. At this moment, you see, the object is at x equals 0. So it's crossing the t-axis, so crossing the origin. At this moment, I go up and then leftward. And I will find the toy car here, you see? So whenever you want to find the location of the object at any arbitrary time, like t, you will go up or down and you will get the graph, and then you continue to the left to find the location of the object, the position of the object. This is exactly as a machine, I mean mathematical machine. Here you will give the t and then the input, and then the output will be x. So it's t and it's x. Let's continue. Here I have something more for you. You know that for all the locations below the t-axis, I will have negative x, means the position of the object is negative. Pay attention, when I say the position is negative, it does not mean that the velocity is also negative. No, it is just the location. According to my convention, here is negative x and here is positive x. So whenever you check any point here, the object is at negative values of x. And accordingly, when the object has a graph above the t-axis, like here, it will have positive x, positive location. That's all. There's nothing that special. We continue with uniform motion backward. Backward means the object is going to move to the negative direction of x. The toy car starts from here and goes down, to the negative side of the x. And so the x graph will be again in line, but with negative slope. You see? It's a descending line. Again, the object will pass the t-axis, will cross the t-axis, and just once it will pass through the origin, but it's nothing that special. Very similar to the previous case. Again, in uniform motion. So uniform motion may start from positive x and go to negative x, or from negative to positive. It's okay. So the initial position, which is the location of the object at t equals 0, may be positive, may be negative, may be 0. In general, I can say let me show you something here. The x graph starting from here will have initial position of x naught, which is 0, an x graph like this, which has an initial position of x naught here, is a positive initial position, and the x graph like this will have a negative initial position. It's negative. It is not that important. Initial position could be negative, could be positive, could be 0. So you will start from any arbitrary point as you wish. Okay, let's continue with accelerated motion. Accelerated motion generally is referred to the motion, that has a changing speed, or it may have a speeding up or slowing down case. Anyway, this car is accelerated. It can slow down, it can speed up, depends. Let's have a combination of them. The car starts from a negative x and then continues to the positive, stops, and then goes back. You see? Let me repeat that again. You see? It's going to the positive direction, then negative direction. Basically here, the object is going forward to the positive direction of x, and then backward to the negative direction of x. At T1 and T2, the object will cross the t-axis, so it has passed through the origin twice. You see? More important than that is this point. Let me show you something here. This point. The car at this point will stop. So this is the turning point. Turning point means that the object here will stop and goes back. Let's check it again. You see? Turning point. But this is the mathematical turning point. Actually, the physical turning point is here because the car will stop here. So the actual turning point in physics is here, but mathematically the turning point of the graph is here. Means that it includes also the time. Turning point is not just a physical point, but it's not just a physical point observable. Something hidden is here, also the time. And so when I say turning point, it will have two components. One of them is something you see, which is the x1, the point, the location, and the other is t, the time of the turning point. So a turning point mathematically will include two components, x and t, x1 and t1. Okay, it's now the peak point of this graph. Also, the graph may have another peak point like this. Let me show you something here. It may be interesting for you. Suppose that the xt graph is given like that. Okay, does it have a turning point? Yes, it does. Here I have a turning point, you see, at t1 and x1. Physically, the object will stop here and goes back. So at the beginning, the object is going down to negative direction of x, and then it will have a reverse motion, you see? Okay, so it could be the minimum point of the graph or the maximum point. So in general, I can say the minimum or maximum for xt graph will be a turning point in which the object will stop and goes back. xt, xt. So maximum or minimum of xt graph. Let's continue with another accelerated motion, which is a little bit more complicated. As you see, the car goes up, goes down, and then goes up. It's interesting. We have two peak points, here and here, so two turning points. How many times the object has passed the origin 1 and 2? You see, whenever it crosses the x-axis, the t-axis, I will say that the object will pass the origin once and twice. Okay, twice. The initial position is positive. Here is positive. And whenever, for instance, at t1, you are going to check the location, the position of the object, it's very easy. Go down, find the graph, and then go to the left. Or even if you are checking the t2, you should go up to find the graph, and then to the left. I told you, you should find the graph and go leftward to find the x-axis. So at t1, the object is here. At t2, the object is here. Tx or tx. Let's continue with the concept of delta t. You are familiar with delta t. You know what the delta t is. It's a time interval. Delta t is t2 minus t1. And then the delta x, which is x2 minus x1. I told you, delta x is the displacement. Here, the delta x is referred as the displacement of the object exactly from t1 to t2. In this time interval, we have this delta x. Okay, we will use all these concepts later. So just be informed that we have something exactly related to the previous concepts we have already learned, like the displacement, distance, time interval, and so forth. And we will learn them again in more mathematical detail when we learn more about xt graph and also vt graph later, acceleration time graph later. They will provide us with more and more information. But the basics is the same. Anyway, we should understand what the motion is, what the velocity is, what the displacement is, and then we will develop those concepts for the mathematical details. Let's have another practice. The object starts from x equals 0, goes to the right, I mean the positive direction of x, and then I show that here, let me show you. I show that here on vertical axis. X here is vertical on XT graph, and here is horizontal, okay? Then maybe we get used to X like this. We always think that the X must be horizontal, but it is not an obligation. Normally, in mathematics, we can draw XT graph even vertical. So the object starts from x equals 0, goes to the right, I mean positive direction of x, and its turning point, then it goes back, you see? This is familiar for you. Do we have any displacement? You say. Yeah, no, there is no displacement because it starts from 0 and again goes back to 0. No displacement, as you see. The next case may start from -4, goes to +4, and then the turning point is here, and it goes back. You see, it has the same behavior, but from different location, initial location or initial position. And the last one will be from -8 to 0 and then goes back. It has also another turning point, very similar to the previous cases, but still no, I don't see any displacement. Okay, this practice also is just telling us the same story in different language. Let me ask a question. Is it possible that an object has the following XT graph? Think about it. Basically, you may think that, oh, yeah, why not? It may be rotational motion, maybe a circular motion, a periodic motion, something like that. But if you think carefully, you may see that it is basically theoretically impossible, and also physically. Why? Suppose that I'm checking the object here at t, okay, at this time. Let's say it's t1. Then I draw a vertical line to find the graph and find the location of the object. It's interesting and very unbelievable because that t1, the object is here at x1 and also here x2. How is it possible? I can't accept it. I cannot believe that the object at a certain moment could be found in two different locations. Oh, okay, so in physics, any physical object may have, no physical object may have such an XT graph. So I don't believe. So I think that XT graph can't be like that. Likewise, if you draw the XT graph like this, it may not be again possible. So I cannot believe again that at a certain time the object may be at this location and also this location and also this location. I cannot believe. It's not acceptable. So in mathematics we say XT graph must be a function. Function in graphical view will be something that a curve or a line, something like this, in which, let me show you, in which when I draw a vertical line, let's say it's XT graph, okay? When I draw a vertical line, it will have maximum one crossing point. So the vertical line mustn't cross the graph more than once. So it's function. If it is a function, it's acceptable as an XT graph. Otherwise, forget about it. It's not physical. Look at this one. An object has the following XT graph. Find the distance and displacement traveled in 3 seconds. Look at this. The object started from x equals -6 and then continued to t equals 2 and x equals 4 and then goes back. So I have a turning point. Let's draw a horizontal axis as x and then show the object. Here I may suppose that this is the origin and then starts from -6, goes to the right to x equals 4. But my graph may not be drawn to a scale, but anyway, please accept it. It starts from -6, goes to 4, and then continues into reverse direction of motion till here. Maybe like that. And at t equals 3, it's finished. Okay, find the distance and displacement traveled in 3 seconds. Okay, it is not going to be very complicated. The distance is the total length of the trajectory. You see the trajectory. The trajectory starts from -6, goes to 4, so it is 10 meters to the right, and then goes back from 4 to 0. It is -4 meters according to the displacement. But the distance is 10 plus 4, the total length of the journey. 10 meters, again 4 meters, so 14 meters for the distance traveled. But about the displacement, we just need to connect the beginning and the ending point. The object starts from -6 and ends at the origin, so this is the displacement. Very easy. It's 6 meters. You see why it is positive? Because we know that we draw the horizontal arrow from left to right, so it is positive. And also on vertical axis, I can show you this one. I start from -6 and I end the vector at x equals 0. So it's delta x. Delta x must be positive 6. But about the distance traveled, I should add up the total length of the journey. 10 meters and 4 meters, 14. That's all. Nothing that special. Sketch the distance time graph of a car with position time graph below. Look at this position time. It is not very complicated for you. You know what the what is the x graph like this. It starts from 0, goes to t equals 2, x equals 10, something like this. Suppose that this is x. It starts from 0, goes to 10, stops here, and goes back. That's all. No displacement, but the distance traveled is 10 plus 10. You see, it goes 10 meters upward or rightward here and 10 meters leftward. So generally the distance traveled is going to be 20 meters, but the displacement 0. What do we want here? The position time graph below. Distance time graph. Let's say the distance is L. Okay, let's take this notation. Distance time graph. How should I show that? I know that from t equals 0 to 2 seconds, the object has a distance of 10. Okay, this is not that complicated. I will draw it like that accordingly. But from here to here, you see that the object also will have again another 10 meters of distance. I know that it's going to the negative direction of x here, but we don't have any negative distance. Distance is always positive. So even if you go back, you are adding up to the previous distance. So again, another 10 meters is added. So I can get 20. So the distance time graph will be always ascending curve, which is always adding and adding up the values to the previous values. So it must be always increasing. What if we have this one? What do you think about this? How the distance time graph is drawn? Think about it. Yeah, you are right. Again, the same. Why? Because from t equals 0 to 2 seconds, the object has displaced for 10 to 0. But anyway, the distance is again 10. Same, 10 meters. Distance cannot be negative. From 2 to 4 seconds, again another 10. So again, I will have this one, and I will get here. So no matter the x graph is this one or that one, the distance time graph will be a 10 plus a 10. Generally, it's going to be 20. That's all. But it has some more complications. You must know how the graph is going to be like this. And here I will have almost 0 slope and then increasing the slope. I will talk about it later because you should know more mathematical details about x graph according to the concept of velocity and acceleration, and you will learn why it is drawn like this. But anyway, don't forget the LT graph, I mean the distance time graph, must be always an ascending curve. Ascending means always increasing. Forget about any uh, complexities, every complexities inside. Let me show you something like this. Look at this one. Suppose that the x graph is given like this. X graph. Look at this. Somebody may draw it like that. Okay, let's say it's 10. Okay, it is 1 second, 2 seconds, 3 seconds, 4 and 5. Okay, totally 5 seconds. And the peaks are always at 10. Okay, how I can draw the LT graph? I mean the distance time graph. Sorry, it's distance and it's time. It's very easy. For the first second, I mean 0 to 1, the object has a distance of 10 and it's linear. So I will draw a line. Okay, t equals 1, here is 10. From here to here, I mean 1 to 2, the object has again a distance of 10. I will add it, again linear, so it's 20. From 2 to 3, it will add again a 10, so it will be 30. It is 2, it is 3. Then I continue from 3 to 4, another 10, another 10, I will get 40. And from 4 to 5, another 10. So finally, I will get 50 for the distance traveled, and it is 5. That's all. Finished. I hope you get it. It is not that complicated. LT graph, I mean distance time graph, cannot have any descent. It must be always positive and always ascending. I cannot understand how can I draw an LT graph with descending format or negative value. It is again unbelievable to have an LT graph like this. Look at this. Suppose that somebody may draw LT graph like this, and I can't understand it because here the distance traveled is negative. Distance by definition cannot be negative. It's not accepted at all. So please be very careful about the concepts. We are learning more and more. So let's continue to learn it in the coming videos and then combine the concepts to learn more. I'm very thankful to you because of watching this video and being with me. Take care and see you in the next video.